we'll talk about polynomial terminology specifically, then adding, subtracting, simplifying polynomials, and then exponent laws themselves. So first, there's a lot of words here, so I want your feedback before I give answers. So first term, what does the word constant mean again? What's a constant? Yeah. Yeah, something that does not change. Specifically with a polynomial, what part of it is the constant? If you think about a polynomial means like a binomial but with many terms, poly meaning many. So more than two terms is a polynomial. So a variable is in the polynomial, but the question is, what's the constant in the polynomial?
Like, for example, 2x, the 2 is a constant?
The 2 is a constant coefficient, yep, because it's a number. What is just the constant by itself? Where do you find the constant in any polynomial usually? How about a linear function or a linear, I don't want to say linear polynomial, it's not, those are like, those counteract each other.
Like the intercept?
Yeah, the last number at the end, like the intercept, the constant term at the very end, that's what we think about for constant. Okay, so this is simply a number. Okay, a constant, the easiest way to remember is it's simply a number. Okay, it's a number, but it's not changing. It's not a variable, because you have a variable that changes and a number that doesn't change. It could be negative, it could be positive, whatever you'd like it to be. But for example here, if we had f of x equals 3x squared plus x minus 7, the constant is negative 7. And by constant, I'm really talking about like a constant term. The constant term is negative 7. 3 is a constant coefficient. 1 is a constant coefficient in the middle. But we're going to get to coefficients in a little bit, so we'll differentiate between those two. Okay, so again, these are constant coefficients. This 3 here and this 1 right here. But negative 7 is really our constant term. This is a variable term. This is a variable term. And this is a constant term. Okay? So in a polynomial, the number that's alone or by itself is called the constant term. How about a monomial? What does monomial mean? Not necessarily the number, but one. Yeah, so let's say one term. Okay, it has one term. So for example, a monomial would be something like 4x squared y to the 5th. That's a monomial. That's all one term. How do I know if I have another term? What is it separated by? What kind of a symbol? Careful.
Or like an addition.
Yeah.
Or a subtraction.
An addition or a subtraction is when I would have another term. And with a binomial, for example, like x plus 2 is a binomial, 2 terms. But if I had 7x y squared plus 2, it's still a binomial. Because the 7xy squared in the beginning is one term, and the plus 2 is another term. Okay? So terms are separated by plus or minus signs. Let's keep that in mind. If you're multiplying a million things together, it's still one term. Is that clear what I'm saying? Again, anything that's grouped together like this, 4x squared y to the 5th, is one singular term. Doesn't matter how many things multiply. Coefficient we already discussed. Ash, you want to point out coefficient again?
3x.
So what's the coefficient there?
3.
Yeah. So it's the number in front of the variable term. The number in front of the variable in a term. Parking around this. You guys zoom in, right? Fit it? Maybe? Maybe not. Not really close. Okay, the number in front of the variable in a term. So, in the previous example, the coefficient was 4, obviously. And as Ashley pointed out earlier, coefficients are traditionally also constants. They're numbers, traditionally. Coefficients can be variables or parameters, actually, too. So if I had like kx squared, where k could be a number, you could say that that's a variable coefficient. Okay, even though it would be a number, because it is a value, it'd be considered like a variable coefficient. K is traditionally used, or c, as variable coefficients. Again, k and c are the traditional ones in math that you use for representing a variable coefficient. What are like terms? What are like terms?
I'm not certain, but I think they're two terms of the same variable, like 3x and 3x squared.
Close. You had it right when you said it, but then
3x and 7x.
There you go, that's right. So there are two terms that have the exact same variable part. You know what like terms are because you've used that phrase before, but they're two terms with the exact same variable component or part. So if we had 7xy to the fifth plus 8xy to the fifth, I can combine those. And that would be 15xy to the fifth. So again, like terms are two terms with the exact same variable component. It sound like a train actually. They have the same variable component. So it doesn't matter what the variable component is. Again, like earlier, it could be x, y to the fifth, z to the seventh, a squared, b to the fourth, all over d to the seventh. That could be the whole variable term. But if the other term has the same variables in it, you can add the coefficients together. Or you can subtract the coefficients from each other. In this case, we would add 7 plus 8 to be 15, and the variable term would just carry down. Polynomial, I already defined polynomial as opposed to a binomial. Polynomial. Yeah, it's in general something with 3 or more terms. Okay, an expression with 3 or more terms.
Is there such thing as a
Binomial. Yeah, it's monomial, binomial, and then you could say trinomial. Some say that, but once it's trinomial onward, the word polynomial is a more generic term. Okay, it doesn't matter what the terms are. I wrote 5x to the 8th plus 2x squared minus 7. That's a polynomial. Okay, it's a polynomial. It doesn't have to be x squared, x, and then a linear term, or it doesn't have to be reducing exponents by 1 every time. Just in general, we have 3 or more terms. How about this next one, the degree of a variable? The degree of a variable. What does it really mean, or what does it indicate to you? Look, you got a hand up? You're just doing this. What does it mean for the degree of a variable?
Just I guess like 2x squared degree is 2.
Correct. So how would you define that? What does the 2 indicate? So let's make it 3x squared, right? So everybody knows. So for 3x squared, the degree is definitely the 2. And Ash, tell us what the 2 actually means.
Like x times x or 2x.
So it's how many times the variable is what?
2.
Fill in the blank though. How many times the variable is what?
The amount of times the variable is multiplied by itself.
Okay, the number of times the variable is multiplied. So if I had a y to the 8th afterward, I'd have 2 separate degrees. The degree of y would be 8, the degree of x would be 2. It's clear, right, that those are separate degrees here? 2 and 8 are completely separate. Now, if I look at the degree of a monomial in general, instead of a variable, and let's say this was my same expression here, the degree of that monomial would be 10. So what does the degree of a monomial mean?
The sum of the exponents.
Yep. Sum of the exponents in a term. Okay, the sum of the exponents or the sum of the degrees in a term. Hey, what's the degree of a constant number? Like 7, what's its degree? The degree of x is 1, isn't it? X by itself, its degree is 1. But if I have a number like 7, where's x? Where'd it go?
It's 7 is x.
7 is a constant, x is a variable. It's technically 7. Come on, somebody figure it out. You guys are smart.
Square root.
No? Hannah?
7x to the 0.
What is it?
7x to the 0.
Yeah, what's anything to the 0 really?
1.
So if I write 7x to the 0, isn't that just 7 really? Think about it for a second. If I were to write 7x to the 0, that's just 7. And some of you know that rule because anything to the 0 is 1. So the degree of a constant is really 0. The degree of x is 1. Because when x is by itself, what's the power? Oh, it's 1. X squared, the degree is 2. X cubed, the degree is 3. But anything that's a constant, you need to think about that it's really with a variable to the 0 afterward. I know that sounds weird, but these are the exact same things because x to the 0 is simply 1. Okay, so the degree of a constant is 0. Remember, the degree is the exponent for the variable, not the number. Sure, 7 is really 7 to the first power. So you think, oh, 7 to the first power, the degree would be 1. It's not, because 7 is 7x to the 0. It's the degree of the actual variable itself. The last thing is the degree of a polynomial, and this one is simply the greatest degree of any of the terms. So for example, if I have this, okay, if I have this set up here, what's the degree of this first term? What's the degree of the first term? 7. Second term? So what's the degree of the overall polynomial? 13. It's the greatest of the degrees. Okay, it's the greatest degree of all the terms present. So this degree would be 13 at the end here. So the overall polynomial would be the 13th power. They're different variables, but again, when I have variables multiplied by each other, the overall degree is the sum of those degrees. Questions on vocab? That's really it for vocab. We're going to get into math now. We need to know these terminologies. It has to be things that you know. If you don't know, what should you make? Yeah, flashcards are always an easy thing to do, especially with math, because ready, on one side, you put the term, on the other side, you put the definition and an example, and practicing, okay? You need to know what these are. You got to know these words. Are any of them confusing? You want to ask any questions about any of them before we go on?
Degree of polynomial. Why would it be like the greatest alternative?
That's just the definition of it. Yeah, so look at it. If you think about the polynomial, when you normally set up a polynomial, you put it from the highest degree to lowest degree. Like in this case, see how it's at the 8 and then 2 and then no degree here? Usually it's written from the highest to lowest. And it's usually, you say it's the degree of the leading term. The leading term is always the front one. So this one, the degree of this polynomial here would be 8, the highest one. So because these were not in order, I have to add them separately, but usually it's the first one. That's all it is.
So, if you had that and like just 3x squared plus y to the 8 plus x, it would be 10 would be the degree.
In this one, you mean?
No, let's just say like for the degree of the variable example, if you just had plus x, the degree would be 10, not 8, right?
Where do you see 10? I'm sorry.
So, but for the degree of the variable there, that's 10.
So this overall monomial degree is 10, correct?
But if you had plus x, the degree of the polynomial.
It'd still be 10, yep. That's right. So you look at each of them individually, each term, the degree, and then the largest of those is the degree of the polynomial. Again, the terminology is really important. You gotta know your words in math. I can't explain how many times when students get to like AP Calculus, they start to struggle because their vocabulary and their arithmetic skills are really lacking. So things like common denominators, things like adding and multiplying fractions, those like small things that you learn, they're going to really play a role later on in math for sure. Vocabulary is one of those things as well. Okay, so make sure you know your terms. All right, this first one is pretty simple. Or not, or simple. We're going to take a look at this, simplify arranging the terms from order from decreasing degree, and then determine each degree of the polynomial. So in this case, we have to look for like terms right away. Okay, arrange them in decreasing degree. So in part A, what like terms do I have? In part A, what are my like terms? Like terms. Ash, give me one. Or a set of two.
X and X squared.
X and X squared.
Like 3x and negative 5x.
Okay, that works. So 3x and the negative 5x are like terms.
Yeah.
That works. What else? What's another set of like terms, Hannah?
Negative x squared and 4x squared.
Okay, see what I'm doing with colors right now in case you're confused? Okay, I'm just associating them with colors. Luke?
Negative 9 and 2.
-9 and 2. Okay, so corresponding colors represent corresponding like terms. That's what I'm showing you. Simplify them by adding or subtracting, depending. So in red, I've got 3x minus 5x. It's negative 2x. Please make sure you understand what I'm doing here with adding and subtracting. A lot of students make mistakes here. This is 3x minus 5x. The coefficient is a negative 5 there. It's not 5x, it's negative 5x. In blue, we've got negative x squared and a positive 4x squared. So I think of that as negative 1 plus 4. It's positive 3. And then finally in green, we've got negative 9 plus 2 is negative 7. So if I put this in the correct order, how do I put this in order of decreasing degree? What does that simply mean? Bridge?
Like the greatest exponents.
Mm-hmm. What do you got?
3x squared minus 2x minus 7.
So the degree is simply 2. Try part B on your own. It's the same thing, just a little bit more complex with the variables. George?
I just have a question about constants. Like, if there's multiple constants, then right here are
You sum them together as like terms. Yep. Which one's the constant you're going to say, right? Now, whenever there's multiple constants, sum them first. So you're trying the second one on your own. I'll underline or highlight so you can see at least. Let me use the highlighter. Let's try that. Actually, that's not a like term in anything, so never mind. There's only a couple like terms in here, they're not all. So it looks to me like there's two sets of like terms. Okay, check what you've seen when you're looking at it. And the ones that are not like terms, those just get carried on. They don't disappear, they just get carried down. Combining the blue terms, I'm going to get negative 6xy to the fourth. Please remember that your variable portion of a term never changes when adding or subtracting like terms. It's the coefficient that you add or subtract together. You never touch the variable portion. In red, I've got 5x cubed y cubed minus x cubed y cubed. So it's really 5 minus 1, which is 4, x cubed y cubed. And then the things without, I just carry down. Is this in? Yeah, go ahead, Rich.
I was going to ask about the 2x for
Yep.
y. Where would that go if you're doing decreasing? Where would that just go second?
So I have to do this first, and then I order them.
Oh.
So look at the order of this. Tell me what it would be. What's the degree of this?
4.
Careful.
Or negative 4.
No. What's here?
Oh, 0. 1.
1. This degree is 5 here. What's this degree? This degree? This degree? So you have to remember, add the exponents to see what the degree is. So we've got degree of 5, degree of 6, degree of 4, degree of 5. So the one with the 6th degree has to go first. And when I say it has to, I don't really mean it has to. It means it's traditionally accepted to write a polynomial in decreasing degree. It's not incorrect, really. But later on, in certain topics, having them in the correct order will make life a million times easier, because this number is called the leading coefficient. It affects a lot of results. So if it's not in the right order and you set negative 6 and say, well, that's my leading coefficient, that's not true at all. It would change the answer up a lot. So your graphs are based on things like leading coefficients. So that's why we put them in order. It's not just to make you have to do more work. Now, there's two terms with a 6th degree, right? Or 5th degree, rather. Here and here. Which one goes first? Which one goes first out of these two? Doesn't matter, guys. It makes no difference. You pick. Okay? All that matters is that the degrees are in order and they are in turn. So if you want to put the 2x to the fourth y first, that's fine. And then minus 6x y to the fourth, that's fine. As long as both of those terms come before the last one, which is x squared y squared. Okay, it doesn't really matter. This should be rather simple, okay? I know I've introduced maybe a couple new terms for you in vocabulary, but combine like terms you've done since like 7th grade, if not earlier. You're looking at exponents you've seen already at least, but we're going to go through all the rules of exponents anyway. So the degree of this polynomial would be 6. The second example is rather simple also. Find the sum. Part A is really easy. Part B, I'll do together only because I want to show you one quick thing for part B. Do part A on your own, please. Sum means add, obviously. Sum means add. You don't need to do this, what I'm doing with colors, I'm just putting it there so later when you see this, in case you're confused about anything, you can see which ones associate with which. If you want to go on to part B, that's fine. Okay, but for part B, we need to recognize here that when we subtract an entire polynomial, we need to really think about that as adding the opposite. Remember earlier in the year, what was the definition of subtraction? It was adding the opposite. So we're subtracting an entire polynomial, so we have to negate all of those terms. So that's the arrangement we have for part B. Making sure that you're distributing, please. This is really a negative 1 out here. So these need to all be the opposites, and then you can drop all parentheses. Okay, so again, drop the parentheses on the next line. And then negate all of those other ones. So switch all of their signs. Does everybody see what I'm saying here? It's the easiest way to subtract polynomials. I know it sounds simple, but there are mistakes made on this all the time. Because students have a tendency to subtract the first thing and then leave everything else alone. You're subtracting an entire quantity, that whole quantity needs to be negated. So this 2y cubed is negative 2y cubed. Y squared, negative y squared. Negative y becomes a positive y, and 2 becomes a negative 2. And then you just simply combine like terms. 6y cubed minus 2y cubed is 4y cubed. After that, negative y squared is by itself, so I'm going to carry that down. There's nothing to combine with. And then I've got 2y plus y is 3y. And then finally, negative 5 minus 2 is negative 7. Alright, so again, like terms, like terms, like terms. Negative y squared has no like term, so it just gets carried down. And notice the degree is in decreasing order. Any hands for questions if you want to go over this more? You want me to go through one of these steps along the way if you were confused? Any questions? All right, let's press on. Simplify the following. You should know how to do this, but again, with like terms you have to use. Remember PEMDAS though, we have to distribute for multiplication first before we start combining any like terms. When I multiply variables that are not the same, I have to remember that we're not really doing anything with them, just putting them after one another. So when I distribute the x to both of these, the 4y times x is simply 4xy. Negative 6 times x is simply negative 6x. Distribute these two. I'm going to have a plus 4x plus 2y. And then finally distribute the 3y. And the 3y is negative. Please make sure you distribute a negative 3y here. That's what we're going to get as a result. We have to combine like terms, put it in order. We got 4xy minus 3xy, combine those, 2y and 6y, negative 6x and 4x. So combine your like terms here. 4xy minus 3xy is 1xy. Negative 6x plus 4x, negative 2x. And then last but not least, 2y plus 6y is 8y. I'm doing like terms with shapes instead of highlighting them every time. Please stop me and ask a question if you want to. The next one's a little bit trickier. If you think this has been easy, go to the next one right away. But if you want to stop and ask a question right now, I'll take some questions. So look at this one. It looks really complicated, but it's actually not bad. It really isn't bad. Try to combine like terms all over the place. Set up the equation so that you have two sides of the equation. And figure out by what's called inspection, by looking at the overall equation, figure out what A, B, and C are.
Yeah, are we able to take away the minus?
Sure. If it's plus, I would drop them right off the bat. Whenever you're adding two polynomials, drop the parentheses right away. So I'm going to highlight like terms. Tell me if this makes sense. That one makes sense, obviously, right away. These are like terms right here. That's the one that's confusing. Look at the green, please. Those are like terms. Because what's the variable term? Variable term is x. What's the coefficient for the first one? 2. The first green term on the left, what's the coefficient? And what's the coefficient here? Negative 2b. See how the coefficients don't have to be numbers actually? Okay, so these are our variable coefficients that will take on numerical values later, but they are like terms actually. And then 2a and 3b, what are they? If a and b are numbers, which they are, what are they then?
Then they're just numbers, not variables.
Which are called? What are they?
Constants.
Constants. These are actually constants. I know this looks weird, but they are. Okay, so look at the overall equation. X is our variable here. X is our variable here. I should have put the directions. Assume A, B, and C are numbers. Right? Now to get it a little bit more clear. So that would be in your directions. Assuming A, B, and C are numbers or numerical values, determine those values of A, B, and C. So how do I combine what's in red, x squared plus x squared, 2x squared? That's the easy one, right? That's the easy one. Luke, help me out with what's in green. How do I combine what's in green?
Would it be just negative?
Yes, you do. You can do it. How do we combine what's in red? Tell me that. Start with that.
We do x squared plus x squared.
So what did you do? Physically. How did you get 2x squared? Where does that come from? Explain.
It's just 1x squared.
Okay, so you did 1x squared plus 1x squared. Didn't you add the ones together to get 2?
Yeah.
Okay. Think about what you did for x squared and apply that to what's in green.
But I don't understand why you can combine.
They're numbers. A and B are numbers. So if they were numbers, if that were 5x and that were negative 2x, you could combine them, correct?
Yeah.
So combine those terms.
Negative -1 ABX.
Close. I see where you're getting the -1 because you're thinking of this minus that, 1 minus 2. Close. Someone want to help me out? Anyone see this? George, what do you got?
Just x, like negative x.
Nope. Hannah?
A minus 2b.
Close. You need to say it a little bit better, Hannah. You said a minus 2bx. I need parentheses or the word, this is like a quantity is a word for that maybe?
The quantity of a minus 2b.
Yeah. So take a look. Ready? Normally I would add the coefficients of whatever it is. This coefficient is a. So go ahead and put an a here. And then I would add the next coefficient, which is negative 2b. And that's the new coefficient there. Can you see the green? Can you guys see the green? That's why I turned the light off. So again, look at your coefficients and simply combine them. You have a and you have a minus 2b. A minus 2b times x. If you don't believe me, distribute the x back out. Go ahead and distribute the x to both. Don't you get back to what you had? Again, if it's not clear to you to see this, distribute x to both of these. You would get ax, that's that, and this would become negative 2b times x. Whenever you have like terms, even if the coefficients are numbers, you still add or subtract them depending upon their signs. How about the last part? Obviously, I can't combine 2b and 3, but I can write it like this. Okay, that's how I can write it, as like a grouping. So I've got, ready? Let me point so you can see. I've got my quadratic portion, which we're going to talk about quadratic soon. I've got my linear portion, and then I've got my constant portion. This is a constant. Since this has x to the first power, it's a linear term, and this is a quadratic term. We're going to talk about these words later with quadratic, but you should know already, anything with x to the 1 is called linear, like a linear function. mx plus b. In mx plus b, what's the exponent for x? The exponent, not the coefficient. The exponent is 1. In the function y equals mx plus b, right? Say this is a function here. The exponent is a 1 there. This is called a linear function. This exponent is a 1 right here. This is called a linear term. If you didn't know that, you should probably jot that down real quick. This one I could be okay with if you didn't know, because we haven't studied quadratics yet, but I know a lot of you have seen those in your previous classes. Quadratic term, linear term, constant term. Terminology, right? You gotta know your vocab. You gotta know your vocab. And guarantee when you have Mr. Linus and he can calculus, he will use words like, point out the linear term or combine linear terms. You need to know what linear terms mean. It means when the exponent is 1. Quadratic terms, exponents are 2. Now, what are these equal? What's on the other side of the equation? Cx, let me zoom out a little bit. On the other side of the equation is cx squared minus 7x plus 3. All right, that's what the original said. Agreed? On the right-hand side, cx squared minus 7x plus 3. Okay, what do you think I should do if I want to figure out what a, b, and c are?
You could.
I'll give you a hint. Tell me what c is first. Figure out what c is. And look at the entire thing. Look at both sides and try to come up with it. All you have to do is look. There's no math involved. So if you figure it out, if you see it, it'll click.
2.
Yeah. How come?
Because it's like each part.
Yeah. Equating coefficients is what this is called. Jot that down. This is called equating coefficients. What Kate recognized, and it took her a second, but that's fine, so it should take you a little while here, is that C and 2 are corresponding to one another. Annette, what is 3 corresponding with?
The constants are 2b plus 3.
Correct. And then negative 7 is equal to?
The x, or the 2 and 2b.
Yeah, a minus 2b, the whole coefficient. So what we do next is called equating coefficients. So 2 equals c, a minus 2b is equal to negative 7, and 2b plus 3a is equal to 3. So all I'm doing now is saying that these two are the same, these coefficients are the same, and these constants have to be the same. Why do they have to be the same?
Because they're equal to each other.
Yes, because this is an equation. That's the whole key. Because this is an equation, each individual part has to be equal to each individual part. That's the only mathematical way that this can be true. Okay? So what do I have as a result? I've got c equals 2, but what else do I have? What do we call this? What's the word for this? Yeah, simultaneous equations, or a system of equations. So how would you get a and b? What would you do? Yeah, either elimination, substitution, or matrix. Either of those. Okay?
That's just mind blowing that just happened. Like, looking at it before, I was like,
There's no way you can solve for these, right? Yeah, you look at it, you're like, this is impossible. But when you think about degrees have to line up. So the coefficients have to line up also. Okay, it's a method called equating coefficients. You use this actually in pre-calc and calculus. It's not even in, actually it might be in your textbook. It might be actually, yeah. But because your text is an old text, I like it a lot. It does a lot of more challenging stuff. So if I wanted to solve this system right here, what do you think? What would you do?
Just add,
Add straight down? How come?
because it's negative 2b and
Yeah, please notice they're not in order. That's the first thing I notice. Some people forget. Look, these correspond to each other, don't they? And those will cancel if you add it right down. So if I add straight down, well, not straight down really, because it's kind of a cross, right? If I add equations, negative 7, sum these, negative 7 plus 3 is negative 4, negative 2b and 2b is 0, a and 3a is 4a, so a is simply negative 1. Which leads me to say that b must be what?
3.
Is that what it comes out to be? 3? Agree, disagree? How do you know you're right? How do you know you're right?
Just plug them back in
Where?
to the
Yeah. Take these values, put them in the original, and see if both sides of the equation are equal to each other. That means you're right. Okay? Again, take A, B, and C. A, B, and C, put them in the original equation at the top. And if you get an equation that equals the same thing, with an expression on each side that are identical, the answer you got is correct. You have a question look on your face. You sure?
no, I got it.
Okay. It just looked like it, that's why I was asking. Other questions at all on this? Okay, good. I think there'll be a problem or two to practice the homework. All right, so I want you to prove to me that these laws are true. Give me an example for the first one to prove that that is true. The first law tells us that we multiply two things with the same base. All we have to do is add the powers. Why? Why is that a rule? You've learned that rule, I'm sure. But the question I'm asking you now is, why is this a rule? Come on, people. You could explain this to me. Give me an example to help. George. Plus? Okay. What was the second one? 3 to the power of? And your answer would be what?
3 to the power of 7.
So tell me why that's true. You're just applying a rule. I asked you to tell me why.
Because
And don't tell me the rule tells add. Think about it.
In the last line, you can agree.
Yes, but just break it up and show me why it's actually true.
If you have both powers of both equal numbers, and when you add those numbers together, it'll create like the power.
Yeah? Guys, you're answering the same question. You both just said the same answer. You gotta listen to each other.
Like 3
Yeah.
to the third power is 3 times 3 times.
Thank you. There we go. 3 to the third is this, isn't it? And what's 3 to the fourth?
It's 4 3s times 7.
So how many 3's do you have?
7.
That's your proof. Very simple. Okay, again, when you think about these rules, if you forget them, just in your mind, write it out as many times as you see it, and then remember what the rule is then. Okay, so if you see x to the 8th times x to the 5th, it's x to the 13th. Why? Because it's x, 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 and then x, 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 x. There are 13 of them in a row, thus you need to add them together. How about the zero exponent rule? Does anyone know the proof of this? This one is not easy to show why. Anyone know why this is true? It's a challenging question. How come number 2 is true? Most people don't know why this is true. I think most of your teachers just tell you. Anything to the 0 is 1. That's a usual thing that most teachers will say. Just memorize it. Anything to the 0 is 1. How come that's true? And it's not a direct proof. It's kind of an indirect proof. Ash? I see you have a look on your face. Yeah, good.
I think it's like if A, like something,
Yeah, you want to write?
yeah.
Sure.
I don't know if it's right because I know there's another rule. It's like if a to b to the power, like divided by a to c equals to a to b and c.
That's a rule, yeah.
And so if it's like 0, you can maybe like a square, a square.
And what do you
is
end up getting?
0, and
Which
it's
is really just
1.
That's a great way to. I've never thought of it that way. That's great, Ash. That's awesome. I'm going to show you another way, but this is absolutely right. So what she recognized was this: the rule for division is that you subtract the exponents. We haven't gotten to that rule yet. We'll get to that, but that is the rule, right? So think about it. If this is a to the b divided by a to the c, it's b minus c. But if these are the same numbers, when you divide two things that are the same, what's the answer always? 1. The overall answer. When you divide two things that are the same, like 7 divided by 7, what is it? It's just 1. So if you think about this, the rule is to do 2 minus 2. And 2 minus 2 gives you what? It gives you 0, doesn't it? But you could also interpret this the other way as saying anything divided by itself is 1. So by definition, if this minus this is really a 0, but this divided by this is really 1, these two things have to be the same. Well done. I've never seen that way to show it. Let me show you another way, okay? Okay, that's a different way to see it. I'm going to show you with numbers. So let's say you have 2 to the third. What's 2 to the third? What is it? 8. What's 2 to the second?
4.
What's 2 to the first? So just look at the pattern. How do you go from each to the next? Divide by? What's 2 divided by 2? That's another easy way to see it. Yeah, to go from power down to power, you go like this.
What is 2 to 1/2?
That's called a square root, actually. Yeah, we'll get to that. So here's what I want you to do, guys. Listen carefully. There are 2 more rules here, Rule 3 and 4, and example 5. Very simple stuff. You need to at least watch the rest of the video. See the explanation for this, please. Look at the explanation for both of these. Don't just assume to memorize the rules. Read example 5 and do the homework over the weekend. Remind me, please, on Tuesday, see you on Tuesday, to go over the Excel issues you're having. Okay? Try to figure them out over the weekend. Maybe look at my template, maybe there was a mistake. Those with dates, that's going to be an issue for sure. So if you correct the dates, that might correct the issue. But try to fix it on your own, compare it to mine. If not, though, we'll go over it on Tuesday. Have a great weekend, guys. Don't forget, I won't forget about I owe you, I know. Tuesday, baked goods and fries. I couldn't do it today. It's first period. Papaya dog isn't even open. I can't get you fries.